By market share in computing devices, Android is the most popular operating system in the world. Today we're going to talk about what it's like to develop apps for Android from the perspective of a new learner or those that are just interested. Welcome to Kopec Explains Software, the podcast where we make computing intelligible. Today we're going to be talking about Android app development. I teach a class called Android Development at the college level. My background is in iOS development, which I did for a few years professionally, but transitioning to Android development found a lot of similarities. Today I'll break down what it was like for myself to learn Android app development and how Android app development is different from iOS development, which will be a nice introduction for those thinking about learning Android development or those who are already iOS developers and just curious about the field.
Let's start with what programming languages are used for Android development.
So the Android operating system itself and most of the Android APIs were programmed in Java. And for a long time, Google actually used their own version of Java. This led to a lawsuit between Google and Oracle, which we covered on a prior episode that I'll link to in the show notes. But the bottom line is today, Android uses pretty standard Java as the basis for a lot of its APIs. However, the Android world has been shifting from Java to Kotlin. Kotlin is a newer programming language that became usable in the Android world in 2017, and Google declared as the preferred way to build Android apps starting in 2019. So if you're thinking about learning Android development today, I would certainly start in Kotlin.
What are some of the differences between Java and Kotlin?
Kotlin has some more modern language features. You can think about it, if you're coming from the iOS world, as analogous to the difference between Objective-C and Swift. Objective-C is the older language that a lot of the APIs on the iOS world are built in, just like Java is on the Android side. But Swift has backwards compatibility with Objective-C in the same way that Kotlin has backwards compatibility with Java and really lives within that Java ecosystem. So it's totally interoperable with Java, but provides newer convenience features that make it easier for the programmer. This is kind of shallow, but in general, you can write things in less lines of code in Kotlin than you can in Java, thanks to some of those advanced language features.
Is Kotlin hard to learn?
I think if you already know Java, or if you know Swift, in fact, Kotlin is pretty easy to learn. Superficially, just looking at it on the surface, Kotlin and Swift syntactically look quite similar. So it's a pretty easy transition going from one to the other. Semantically, how they work beneath the surface is actually quite different. But on the Android side, Kotlin is fully interoperable with Java, so you can actually use any third-party Java library directly in your Kotlin code.
So you don't lose the resources of Java by switching to Kotlin?
Not at all, and it totally makes sense if you're learning Android development for the first time to just learn Kotlin. However, the exception to that would be if your intention is to work within an older code base. Most older Android code bases are going to be in Java.
Let's shift now to frameworks. What are the frameworks that exist for Android development?
Yeah, the main Android API, some people find a little bit Byzantine, and I will say learning it myself, and I was learning it back in the 2016 timeframe, I found it that way. I found it a little overcomplicated, a little over-engineered for some of the things that you want to do easily in it. From a UI standpoint, a lot of older Android development was done in XML layout files. So these are resource files that your app talks to and inflates the UI components from. So it's good to know a little bit of XML as you're learning Android development as well. There is a layout designer in Android Studio, and Android Studio is the main integrated development environment that's used for Android development. But I've always found it a little bit buggy, and being able to dig into the XML layout files yourself, I always found helpful. The Android APIs are vast, and there's many of them, and it can feel a little overwhelming when you're first learning. I do recommend using structured tutorials or a good book. When I was learning Android development for the first time, I read from cover to cover the Big Nerd Ranch Guide on Android programming, and I'll link to it in the show notes. It's actually just came out with its 5th edition, and I think it's a really great resource. An interesting thing about the Android frameworks is that most people don't build directly against the APIs that come with the operating system. They actually build against what's called the support library. And the more modern version of the support library is called Android X, and it's a part of the Jetpack package of libraries that Google distributes. We'll talk in a few minutes about the problem of fragmentation in the Android world, which explains a lot of why the support library is used, specifically Android X today, instead of just building against the APIs that ship with the operating system. However, there's a newer way of doing Android UI layouts, and it's called Jetpack Compose. It allows you to declare the UI in a declarative fashion in code instead of using XML layout files. And I think it's going to become the preferred way of doing Android UI development going forward. We're kind of in an in-between world right now, so probably the best thing to do if you're learning Android today is to learn both the traditional APIs, which a lot of older code bases will be built in, and to learn Jetpack Compose. But if you're doing wholly greenfield development, building something completely new, you could probably just start with Jetpack Compose.
Let's talk a little bit about this fragmentation problem you mentioned. Can you tell us a bit more about it?
Yeah, one of the biggest problems in the Android world is fragmentation. What this basically has to do with is many different kinds of devices with many different versions of the Android operating system. The reason for this is that Android is mostly an open ecosystem. Google develops Android with the help of some partners, but largely on their own. And they distribute Android to many different OEMs. And in fact, anyone can become an OEM that uses Android as their operating system.
And what's an OEM?
An original equipment manufacturer. So basically a hardware developer, somebody who creates a mobile phone or a tablet. And they end up adding Android on top of the hardware that they've packaged together, right? But they're all creating slightly different hardware, different screen sizes, different microprocessors, different peripherals, different firmware for those different peripherals. And so they're shipping slightly modified versions of the Android operating system. And because Android is open source, they might actually be modifying it to a greater degree. Some will even change some of the UI components as well. So what you end up with is many different hardware manufacturers shipping many very slightly different versions of Android. And then those slightly different versions of Android need to be updated as new versions of Android come out. And what will happen is many hardware manufacturers won't have the resources to keep updating slightly modified versions of Android for older versions of their devices. And so after a couple of years, their device will get stranded on a certain version of Android. So in the Android world, there's a lot of fragmentation. There's a lot of devices running different versions of Android, which is very different from the iOS world. In the iOS world, because there's only one hardware manufacturer, Apple, everyone is basically running either the latest version of iOS or the last version of iOS, and very few devices are running very old versions of iOS. Whereas in the Android world, many devices are still running older versions of Android. I think the current version of Android is like Android 13. There's many people still running Android 7, Android 8, even people running Android 5 still. And for that reason, it's hard as a software developer to go and support every possible different device with every possible different version of Android. What's the solution? There's no solid solution to answer this problem altogether because you still need to do a lot of testing, right? If you're an Android developer, you need to go test on a wide variety of devices because the ecosystem is so fragmented. But the solution that does exist are what are called the support libraries, and the current support library is now called Android X. Instead of developing against the base APIs in the operating system, you develop against the support library, which can then be shipped with your app and will then allow your app to work with any version of Android that the support library supports. So even though you're building in 2022, you're building against a support library that can be bundled with your app and will allow your app to work with versions of Android that might have come out in 2015. The other benefit of this is that Google can keep updating the support library, and an app that works with the support library and still runs on an old Android device is still getting bug fixes, security fixes, and even new features that it can incorporate through the support library. So the support library is a way of trying to solve the fragmentation problem for app developers.
It seems very complicated to have that.
It does add a bit of complexity. In practice, you just always build against the support library. So you're not usually building your app against APIs that are just built into some old version of Android. You instead are just shipping against the support library. So as long as you're aware of this and you're updating the support library as the support library gets updated, you're getting all these benefits and not really having to think about it too much. But it is important to know about the support library and build against the support library so that you're not tying yourself to old APIs and an old version of the OS just to be compatible across a broad range of devices.
There also are some popular third-party frameworks, is that correct?
Yeah, like on any platform, the OS vendor, Google in this case, is not able to create the perfect version of every possible library that you might need. So there are many popular third-party libraries that often get used in Android apps. One example is OKHTTP, which I think is developed by Square. It's an HTTP request library that you use for handling web APIs, and it works a lot better than the built-in HTTP libraries in the Android base libraries. So almost everybody uses OKHTTP instead of using the HTTP libraries that come with Android.
How do you test an Android app?
So Google ships emulators with Android Studio, and they're pretty easy to configure and launch. And generally, to have a fast refresh cycle, to be able to write your code and quickly see the changes, you will have the emulator open all the time, be running it again, seeing the results in the emulator. Of course, that's not the same as testing it on a real device, and it's always important for a serious app to do both. And because the Android world is so fragmented, in an ideal world, you'll actually own multiple different kinds of popular Android devices and be regularly testing your app on real hardware. Of course, there's also unit tests, integration tests, UI tests like there are on any platform. And in the ideal world, you're also releasing betas of your app that allow third-party users to go and test your app as well. One nice thing is in the Android world, as opposed to the iOS world, there's sideloading. So you can actually ship your app to somebody and they can install it on their device without having to go through the Play Store, some kind of lockdown distribution model. So it's easier to get your app out to people to test in the Android world than it is in the iOS world, and there's more solutions for doing so because sideloading is a possibility. And I should mention that's a big difference in the Android world and distribution as well, right? You can actually sell an app directly from your website or from a third-party app store in the Android world, which you can't do in the iOS world. If you want to sell a consumer app in the iOS world, it has to go through the App Store. Whereas on the Android world, you could have somebody just download the app and install it themselves, or you could sell through an app store that's other than Google Play Store.
What are some of the similarities and differences, other than maybe the ones that you've already touched on, between developing for iOS or the web and Android?
Yeah, I'm going to limit talking to just iOS versus Android because the web is just so far afield. The only thing I'll say about the web in general is the web has a very fast refresh cycle and absolutely no distribution problems, right? You put something up on a site, anyone can access it right away. And when you're developing, you don't even have to wait for the emulator to reload your program. You just hit refresh and you instantly have a new version of your code. So those are some benefits of web development over either Android or iOS development. But in general, Android versus iOS, we did an episode called Android versus iOS that I'll link to in the show notes. But as a developer, there are a lot of similarities. Like both are obviously mobile platforms, so you have limited connectivity sometimes as somebody moves around. You have limited resources. You don't quite have the RAM and CPU power that you'd have on a desktop. You have to be mindful of battery life. So there's a lot of similarities no matter what kind of mobile development you're doing. From a language and framework standpoint, the older frameworks, UIKit on iOS and the standard Android APIs and support libraries on Android, are both model view controller oriented libraries in terms of the paradigm. And that's kind of beyond the scope of our episode to go into what that means. But if you know how to develop apps on one, you'll find familiar paradigms on the other, as even in the newer framework. So the newer framework on iOS is called SwiftUI. The newer framework on Android is called Jetpack Compose. Both are declarative frameworks where you define the layout of your UI in code instead of using a design tool. So they have actually a lot of similarities in terms of paradigm. They've both kind of moved a little bit towards what's called functional reactive programming. So they both are using similar software engineering paradigms. The languages, like I mentioned earlier, even superficially look similar. So Swift and Kotlin, which are the modern languages for iOS and Android development respectively, if you're just looking at the syntax, if you know how to read Swift code, you can probably read Kotlin code. So superficially, they look similar. Beneath the surface, they're quite different once you get into the weeds of it. But the nice thing about that superficiality is you can probably pick one up from the other at a starting point, like getting ready, just learning the first bits pretty quickly. Of course, the biggest difference between the two is that iOS is a really locked down platform. You're really just allowed to play in Apple's sandbox, whereas Android is very much an open platform where you have possibilities for side-loading distribution or multiple different app stores. And just globally, there's also a big demographic difference. Android is the bigger operating system globally. You have an 80% of the world audience with Android, but iOS is much bigger in some developed markets. Like in the United States, it's more 50-50. Also, iOS users, because iPhones tend to be more expensive devices, tend to be wealthier. And so oftentimes if an app is coming out for both platforms, and it's a paid app, they'll often test first on iOS, because if you can't do well on iOS with those wealthier consumers, it's very unlikely you're going to do well on Android. So for a long time, it was kind of a thing that apps would get released first on iOS and later on Android. And that is still kind of the case because of those demographic differences. If you can't make it with the wealthier iOS users for your paid app, you're probably not going to make it on Android.
You mentioned it earlier. Let's dive in a little deeper to the development environment, Android Studio.
Yeah, Android Studio is the main integrated development environment that's used in Android development. It actually grew out of an earlier version, which used to just be a plugin for other development environments. There was like an Android development plugin for Eclipse and other Java IDEs. And after a while, Google started directly working with JetBrains. JetBrains are a big integrated development environment maker. They also actually are the creators of the Kotlin language. And Google started directly working with them to take their IDE platform and develop Android Studio. So you could say in a sense that Android Studio is a collaboration between Google and JetBrains. JetBrains IDEs actually are based on open source components. So I don't know how direct that relationship is, or if it's more of a working relationship in that they're using their open source components and building off of them. Anyway, regardless, if you're familiar with the JetBrains suite of IDEs, you're going to feel at home in Android Studio because it's built out of them. So there's a lot of similarity there. I think Android Studio is a fine IDE. It's improved a lot. I found it very buggy 6 years ago when I was first learning Android development. I think it's really gotten refined, a lot more performant over the years. It has the debugger and the layout design tools all built into it, so it's really integrated very well. And it also has the emulator actually in recent versions has been fully integrated into it. It used to be like a separate app, but now it actually runs from within Android Studio. So it's very much a seamless environment. I still run into bugs once in a while, and it still sometimes feels, especially that the build system is kind of being held together by thread and duct tape. So it doesn't always feel like the most solid platform. That said, it's a very complex platform, so I'm sure they can be excused for having some bugs. You do have alternatives. I mean, there are other IDEs that you can do Android development in, but for practical purposes, not very many people use anything other than Android Studio because it's so ubiquitous, it's free, and it has every feature that you can imagine. And you don't kind of want to be the one person building an app on an odd platform and then have compatibility issues. So overall, it's fine. It's not as performant as Xcode, which is the main IDE used for iOS development, either from build system perspective, compiler perspective, performance of just editing things in the IDE itself. Xcode has had its own share of problems over the last few years, but certainly more performant. I'd say it has less refactoring features, Xcode, than Android Studio. So Android Studio, you could argue, has more powerful built-in features, but is a little bit less performant and maybe a little bit more buggy in my experience on a day-to-day basis.
What advice do you have for someone who's just getting into Android programming?
Yeah, a bunch of things I'll reiterate from earlier. First thing is I really think it's good to have a good book or a good tutorial to learn from. And I do recommend the Big Nerd Ranch Android programming guides, and I'll link to the most recent edition that just came out. And it's actually important to use a really recent tutorial or book because Android does move quite quickly and the APIs do change quite a bit over time. For example, if you were using the 4th edition of their book from 3 years ago, it didn't cover Jetpack Compose at all. But in the most recent edition, the 5th edition, they've added 4 chapters on Jetpack Compose, and Jetpack Compose is becoming very popular. So you wouldn't want to be learning Android today probably without learning about Jetpack Compose at all. The other piece of advice I have is that I don't think it's a good first platform to learn programming on. The APIs are just complex enough, the platform is big enough, it can be overwhelming enough that I think it's not a place to first learn programming from. I would suggest you start doing Android development after you've already learned maybe one other language, one other platform. It could be that you just learn Kotlin and learn how to do command line apps first in Kotlin before you start using Kotlin to create Android apps. That would be fine, and that would be a nice gradual pathway to getting up to Android development. But if you've never programmed before, I wouldn't just start by diving into Android programming. I think you will find it a bit overwhelming. The class I teach, Android Development, which is a college level class, is actually designed pretty much for juniors. So for people that are in their third year of college and already have 2 years of programming classes before they get to it. And I think that actually is pretty logical. I do think that the APIs as a whole can be a bit overwhelming. I think the APIs are overly complex, some of them. I've sometimes taken the same app that I've built in iOS, and I've actually done this with an app I've actually released. So I wrote one version of it in iOS, and I wrote another version of it for Android. And the Android app can often be like 50% larger than the iOS app. There's just more complexity there, more hoops to jump through. Some things are just easier to do in the iOS world. As a whole, though, I mean, they to their credit, they're constantly evolving Android. It is getting better all the time. And it sure beats 1990s Windows or Mac development, which was really overcomplicated and hard. Okay, thanks for listening to us this week. We want to remind you to like us, follow us, subscribe to us on your podcast player of choice. If you've been listening for a long time, we're coming up to our 100th episode. It's hard to believe, but we really appreciate if you leave us a review on that podcast player of choice. Rebecca, how can people get in touch with us on Twitter?
We're at Kopec Explains, KOPECEXPLAINS.
We've had many listeners reach out to us over the past few months suggesting topics. Really appreciate that. Appreciate everyone who listens, and we'll see you in 2 weeks.
Bye.